Hello everyone, welcome to my channel, and in this lecture we are going to talk about the nomenclature of internal combustion engine. So without further ado, let's get into it. In the previous lecture we have covered all the components, major components of IC engine with their functionality. So our first dimension or the first nomenclature is bore. So bore is nothing but a diameter of a cylinder. So in this case, this diameter is known as a bore. So our next dimension is piston area. So the piston area is nothing but the area of circle in which the diameter is equal to the bore, which means the diameter of the cylinder. Because as we know, piston and cylinder are tightly fixed. Therefore, we consider the bore, which is D, for the piston area calculation. So in this case, the piston area, which we call it as A, is equal to pi by 4 d square, in which the d is bore diameter. So our next dimension is TDC, which is a top dead center. The TDC is nothing but a position in which the piston is at its upmost position. So whenever the piston is in the upmost position, that position is called as a top dead center, or we can call it as a TDC. Similarly, BDC. So BDC is nothing but whenever the piston is at its lowest position, that position is called as a BDC, or a bottom dead center. So far we have covered bore, piston area, TDC and BDC. So the next topic is very important, which is a stroke. So the stroke is nothing but a distance between top dead center and the bottom dead center. Stroke is nothing but the distance in which the piston reciprocates inside the cylinder. So the piston travels from TDC to BDC and again BDC to TDC. This distance is known as a stroke. We will denote stroke by L letter. So our next topic is stroke to bore ratio. Stroke to bore, L by D. So stroke to bore ratio is very important when classifying the type of engine. So whenever the D is less than L, it means that the engine is under square engine. Whenever the D is equal to L, as the stroke is equal to the bore, then it is called as a squared engine. And whenever the L is less than D, so in this case it is a over squared engine. So the over squared engine operates at very high speed, as the L to D ratio will be the higher for it. We will discuss it in the next lecture. So our next important topic is swept volume. Swept volume. So swept volume is nothing but a volume which is occupied whenever the piston moves from TDC to BDC. So whenever the piston moves from TDC to BDC, the volume, the total volume which is covered during one rotation of the crank, which is known as a swept volume. So the formula will be very simple. So as we know, this is L and this is D. So L and D. So the swept volume, as we know, area into the length. So the area will be pi by 4 d square into our L, which is nothing but a stroke. So this is a swept volume, which is very important when specifying the size of the engine. Our next topic is very important, cubic capacity of an engine. Cubic capacity, or we can also call it as CC. So what is this CC? You have always heard this CC whenever the specification of engine comes into your mind. Cubic capacity is nothing but a swept volume, which is Vs multiplied by the number of cylinder in the engine. So whenever we are dealing with the multi-cylinder engine such as a 4-cylinder or a V8, which is a V-line 8-cylinder engine. So this formula will come in place whenever the calculation of CC will happen. So CC is nothing but swept volume multiplied by the number of cylinder. So for the single cylinder engine, swept volume will be the cubic capacity of an engine. So the next topic is clearance volume. So let me clear this. Clearance volume, which is denoted by VC. So clearance volume is nothing but the volume when the piston is at the upmost position, which is TDC, and the cylinder head. So clearance volume is nothing but the volume which is occupied between the piston and the cylinder head whenever the piston is at the top dead center. This volume between the piston and the cylinder head will be the clearance volume. So this is a VC. So in this clearance volume, the combustion process takes place by ignition of a air fuel mixture. And our last topic is a compression ratio. So let me tell you one thing here. So far, this is the most important topic in our whole lecture. Compression ratio. Compression ratio, the definition of compression ratio is nothing but the total volume occupied by the cylinder whenever the piston is at the bottom dead center. So we will call it as a clearance volume. So this is a clearance volume as we know. So the VC plus this is a swept volume. The swept volume, which is Vs, and the VC. So compression ratio is nothing but a ratio of the total volume occupied by the cylinder whenever the piston is at a bottom dead center to the clearance volume of a cylinder. So the total volume will be Vs plus VC, Vs plus VC divided by VC. So this is the most important formula in our today's lecture, and we will denote compression ratio as a R. So let me tell you one thing. So compression ratio is very important when dealing with the thermodynamic calculation that we will see in our next lectures. So I hope you understood what is the basic nomenclature of an IC engine. So in the next lecture, we will going to see the various thermodynamic cycles in the IC engine, which is Otto cycle, diesel cycle. We will discuss it in the next lectures. If you like this video, please subscribe to my channel and also ring the notification bell to get the latest content. Thanks for watching.